Day 4, problem 1. A pole is 4 feet high and casts a 6-foot shadow. At the same time of day, a nearby tree casts a 20-foot shadow. Question A, sketch a diagram. So here's the ground. And now a pole, so just a little line coming up out of the ground, that's the pole. And nearby there is a tree. So how about here's our tree. Now for there to be shadows, there has to be a sun up in the sky. And so I might draw the sun just up here to the right. And that's going to create shadows which are to the left of the objects. Okay. Now let's focus our attention on the pole. We're told that the pole is 4 feet tall and it casts a 6-foot shadow on the ground. So there's a dark spot on the ground that is 6 feet long. And the idea here is that this creates a right triangle shape. So here is a right triangle located at the pole. The pole is 4 feet tall and the shadow is 6 feet long. Now the tree casts a 20-foot shadow. So there's a dark spot to the left of the tree that is 20 feet long. Now the height of the tree. We don't know how high the tree is. In fact, that's what we're asked to figure out. So let's put a variable on that, like x. The idea here is that the tree and its shadow forms a right triangle. So here's a side of the triangle, and then diagonally down to the tip of the shadow, and then along the bottom where the shadow is a right triangle with a 90-degree angle. So here is our diagram for question A. Now question B, use similar triangles. These are similar shaped right triangles. And a proportion to find the tree's height. A proportion is an equation that has a ratio to the left side of the equals and a ratio to the right side of the equals. Let's create these ratios by using measurements in our drawing. Okay. Start by looking at the pole. The pole is 4 feet tall. So 4 feet is the height of the pole, and it has a 6-foot shadow. So I can put 6 here, and what I'm doing is I'm making a ratio comparing the height of the pole to the shadow of the pole. So height on top, shadow on bottom. Let's make a ratio here about the tree. Height on top, shadow on bottom. So the height of the tree is x, and the shadow of the tree is 20. And so we have the proportion 4 is to 6 as x is to 20. Now there's a lot of ways to solve proportions. Sometimes it's possible to see patterns that are evident, and then you can use those patterns to quickly find an answer for the variable. And other times it's fastest just to solve the proportion as an equation. And that's what I'm going to choose to do here. Here is an equation that has the variable x, and next to the variable x there is divide 20. I'm going to remove the divide 20 by doing the opposite math. The opposite of division by 20 is to multiply by 20. So on the right side of the equation, times by 20, and to maintain balance, on the left side of the equation, times by 20. I'm multiplying by the same number on both sides of the equation. Here's what happens when you do that. This 20 will cross-cancel this 20 because 20 divide 20 makes 1, or just 1x. So I can cross these 20s out, and I'm just left with this 1x left over. That's what I was trying to accomplish, to have the x alone. And so that makes x equals. Now on the left side of the equation, what does this make? 20 times 4 is 80 on the top. And then there's the divide 6. So this is like getting 80 over 6. But what is 80 over 6? Let's figure this out. 80 divided by 6. So maybe some long division. 6 divides into 80. 6 divides into 8 once, and 1 times 6 is 6. And subtract. Now bring down this next digit to create 20. 6 divides into 20 3 times. 3 times 6 is 18. And subtract 2. Now what we can do is put a decimal point here and move that decimal point straight up above to put it here in the answer that we're creating, and add an additional 0 into the problem. And that 0 can be brought down next to the 2 to create 20. 6 divides into 20 3 times. And 3 times 6 is 18. But 20 subtract 18 is going to be 2 again. And if I put another 0 on here and bring it down by the 2, I get another 20. And so what's going to happen is that this digit 3 is going to repeat 3, 3, 3 forever. And the way that you can show that a digit repeats is to put a bar above it. And so our answer for x is 13.3 repeating. So 13.3 repeating feet. And that is how tall the tree is. Now day 4, problem 2. We have 4 arithmetic questions to do. So let's start with question A. -8 times +7. Negative times positive is negative, and 8 times 7 is 56. Question B. -50 divided by -10. Negative divided by negative is positive. 50 divided by 10 is 5, so positive 5. Question C. 5/6, subtract 2/3. Okay. Now subtracting fractions, just like adding fractions, requires that the denominators be the same. And right now, the denominators are not the same. This is 6 and this is 3. So let's make the denominators the same. I can multiply this by 3 and this by 3. And then the first fraction, which was 5/6, can be rewritten as 15/18. Now we can take this fraction and change its denominator to an 18 as well. So times by 6 times by 6. This becomes 12/18. And now that the denominators match, we're able to subtract these fractional pieces of an object. 15/18 subtract 12/18 is 3/18. Now 3/18 does reduce. This number and this number can both be divided by 3. So let's see what that would make. 3 divided by 3 makes 1 for the numerator. 18 divided by 3 makes 6 for the denominator. And so the fraction 1/6 is the simplified answer to the subtraction problem. Now question D. 16 divided by 1/3. Again, sometimes it's hard to visualize in your mind what dividing by a fractional piece means, and so it's often easier to change the dividing problem into a multiplying problem. And the way that that can be done is to use reciprocals. Dividing by 1/3 is equivalent to multiplying by 3/1. 3/1 is just the same as the whole number 3. And so this is 16 times 3. 16 times 3 is 48.